I will start with a challenge. Suppose they ask you to write a program that outputs the numbers from 0 to 1 million in sequence. How do you write a test for this program? Any idea? Let's say it produces a list of numbers. Let's simplify it. It could be that you have to test that it prints them somewhere. But let's make it simple. You have a function that outputs the numbers from a list of numbers from 0 to 1 million. You have to test it that it outputs correctly. The program is simple, but how do you test it? Let me first introduce myself. So while you think about this problem. So basically, I am a programmer who at some point around the year 2001 heard about extreme programming and started to study and learn mostly by myself, but then at some point I met a teacher, Mr. Francesco Cirillo, who taught me a great deal. And I also met a team that we also learned a lot together. From 2006 to 2012, we worked together. And along the way, I started coaching teams, not just programming. And I invented some exercises like the birthday greeting kata, the open close principle lab, the simple design in action lab, and one project that went particularly well for my team was a banking project that we delivered with satisfaction of the customer under extremely difficult conditions. And we did it by applying extreme programming to the full. We applied all the quality practices that we knew about. And then around 2015, I started working with ThoughtWorks. And basically, that's it. These are some of the questions about TDD that you might have. I'm not sure that you have these questions. Maybe you have others. Let's talk about how we start doing TDD. So you have a blank page in front of you. You are given a problem to solve, and it looks like this. A large block of marble, and you have to somehow start chipping the marble and obtain a beautiful statue. Well, how do you start? So there's several strategies of applying TDD to start solving a new problem. One is the one recommended by Kent Beck is starting with a list. You know, Kent Beck is the inventor of test-driven development. So you start by the list. What do you have in this list? You put in examples of the business problem that you have to solve. And at first, you don't want to put the technical tasks in the list. Why? Because what you want to do is to think about the problem, not about the solution. You want to let the solution as much as possible be determined by what is necessary to make the test pass, not by our idea, I know how things work, I will have to do this and this and this. Because when we start reasoning about a problem, we being as programmers, we immediately tend to see a solution. If we start implementing this solution, we lose on many benefits of TDD. Because one of the main benefits of TDD is that I do only the minimum work necessary to solve my problem, no more. And a good way is to concentrate on examples of what I have to pass. So this is the example in the TDD by example book is about implementing multi-currency money. And the examples that Kent Beck starts with are, if I sum $5 and 5 francs, the output would be $10 if the rate of exchange is 2 to 1. And then I must be able to multiply $5 by 2 and get $10. Examples. There's nothing here that tells you how you should implement it. So let's go back to this problem. What would be the list of tests here? Bravo. That's a good solution. So the audience of CodeMotion in November didn't find this solution. So the kind of solutions that we had were, so this is one. You try to check the first two numbers and the last two numbers and check if they're correct. Okay, this gives me some confidence, but is not satisfactory. Or you could use an algorithm, which is something similar to what you were suggesting. So I have a program here that tests from 0 to 1 million, and I check that I is equal to the result of the program at I. What is the problem with this approach? So you have an algorithm that you want to test, and you test it with another algorithm. So there's a risk that both algorithms have defects. So if this is a program and it contains a loop, it might contain an error. If I make a off by one error here, probably I make the same mistake in the production code. So I think I'm covered by the test, but I'm not. So generally, what I want to have is that the test code is different from the production code. And generally, I don't want to have any ifs or cycles in tests, because these force me to reason about what the test is doing. I don't want to reason about the test. I only want to reason about the program or production program. So this I don't like, because the test is as complex as the program it must test. So another try. So this is one I saw in an interview program that I sent. So the guy wanted to test that his Roman number conversion program worked. So he supplied a list of 4,000 conversion in a file and checked that his program was correct with every line of this file. What was the problem of that approach? You have 4,000 test cases in this file. How do you make sure that they are all correct? If I read each one of them, it takes me a lot of time, and I'm certain that if there's a mistake, I miss it. So this gives me no confidence at all that the program is correct. It tells me that it is the same as the file, and then I have to test the file. So this is a good solution for me. So you take the initial problem and you generalize it slightly. So I want to write a program that produces sequences of numbers from 0 to n, varying n. And I start with n equals 0, n equals 1, n equals 2. And if it works for these three cases, I'm fairly confident that it works also for 1 million. So let's remember that the tests that we write for TDD are not the tests of testers. These are tests of programmers, and they're meant to support us to build the software. They give me a reasonable network of safety, and they also push me to do some good generalizations. So this program, generate from 0 to 2, is better than generate open closed parentheses, because the other one is more rigid. This is a more flexible program, more general. A good test list, as we said, contains examples of the problem that we need to solve. And these examples should cover all the variations of the business problem that we have to solve. And another way to call these variations is scenarios. So when you have a problem, a user story, let's say, you have a number of scenarios, at least 2. Even the simplest user story at least has the success scenario and the failure scenario. So everything goes well, something goes wrong. Usually, if you have something complex, you have more ways to do things that works correctly and more ways to fail. So you want to have a separate test for each of those. So for every scenario, you have a test. Sometimes the problem that you want to solve is too complicated. So you write a test, and it takes you a long time to pass the test. What do you do then? Remember that the cycle of TDD is meant to be fast. Red, make it pass quickly, then refactor. If I'm in red with a broken test, and it takes me a lot of work to make the test pass, I'm in a bad position, because I'm getting no feedback. the thing I want from TDD is fast feedback on the quality of what I'm writing. So I write something that's good, I want the test to be green. I want something that is bad, I want the test to be red. If it takes me 10 minutes or 15 minutes of work, I'm writing many lines of code, and I have no feedback on any of these lines of code until I'm done, if I'm done. So this is bad. This puts me in a bad position. When this happens, I ignore the test, comment it or whatever, and then start writing a smaller test. I do something that I think it takes me closer to solving the problem, whatever. So I do what Kent Beck calls children tests. So then once you've selected the example that you want to solve, you have another problem. You have to decide how you solve it. So there's one style that says, I put myself in the feet of someone that is looking the program from the outside, so I act on the user interface of the program. So I send a stimulus, I observe the output, and this allows me to start working from the outside in. And I start solving a slice of the problem, maybe only covering the UI, then I go further, implementing something in the domain logic, etc., etc. So this is one style. There's another point of view that says the important part that I want to solve is about the domain. So I start solving the domain. And think if I was to implement the Game of Life program, which you know is a game that changes a grid of cells, they become alive or dead in successive generations according to rules. So one approach would be I design a screen, maybe made of characters, asterisks and spaces, and I test that this scheme of characters is transformed in another scheme of characters at the successive generation. This is outside in. Or I start implementing a cell object that is alive, and I give this cell a number of neighbors, and then I test what happens. Does it become dead, or does it stay alive? So these are two approaches. Which one is better, in your opinion? Outside in or inside out? What would a consultant say? A consultant probably would say it depends. And in fact, this is what Kent Beck suggests. So the really important thing is to make light where you have darkness. So what is the part of the system that you have the most doubts about? This is where you want to go and explore. So if your problems are with the domain, because the domain is a big unknown to you, you start working in there. If you are using a technology that you don't know well, like a new UI framework or something like this, you start testing from the UI, because you're making light where you have the most doubts, the most unknowns. So the movement that we want to make is from known to unknown. Kent Beck says, you should pick a test that will teach you something, and you're confident you can implement. So something that is not too difficult, and something that is interesting. If you're getting bored while doing TDD, you're not following this advice. You should do things that are interesting to you. If you're getting bored, something's wrong. You should solve a problem that is difficult enough for you, not too easy. Now, there's one thing that most people doing TDD forget. And I'm talking about the vast majority of people doing TDD. Why they forget it? Because it is explained in the book of Kent Beck, but it's difficult to get because it's a single line in one page, and it does not elaborate a lot on it. But over the years, I understand that this is one of the most important things about TDD. And so I'm going to share with you this thing. And this is about orthogonal access. So remember the problem of 1 million numbers. We solve it by making it smaller. So we have a big problem. We postulated that first we want to solve a very small version of it, a seed of the problem. Starting from the seed of the problem, we start building and adding complications. What do I mean by this? It all comes down to separation of concerns. You don't want that you have many tests that fail for the same reason. You want to separate your tests so that if I have an error in my display logic, one test fails, not all of them. If I have a test in my logic because my computation is wrong for when n is equal to 42, then I want the test for n equal 42 to fail, and nothing else to fail. One error, one failed test, one error in the code. When I touch something and many tests break, it means that my tests are not separated, isolated enough from one another. And this is what Kent Beck says. How should the running of tests affect one another? Not at all. If I had one test broken, I wanted one problem. If I had two tests broken, I wanted two problems. But this is not easy to achieve. If you want to isolate the test, sometimes you have to work very hard to break the problem into simple pieces that are independent from one another. Because the problem is not just in the test. The problem is that if your thing that you are trying to test does many things, when it breaks, it will break many tests. So the idea is, how do I separate my production code so that everything I'm interested in is separate so that they can break independently? And this is why this is overlooked by many, because it is here at page 125 of TDD by example, and he never talks again about it. Not before, not after, only here. But when I worked with people who learned TDD from Kent Beck, which is Francesco Cirillo, and people who learned from Francesco Cirillo, I saw that what they do, they start with an arbitrary simplification of the initial problem, a seed, very small, and then they start adding complications one at a time on separate different complexity axes. For instance, let's skip this. For instance, take the Tetris program. If you want to write a program that plays Tetris, you have many things to be worried about. But if you follow this advice, you start with the simplest version of the Tetris game that you can imagine. What that could be? A single line. That's a good idea. Or a single column. So there's a very good article that taught me a lot. It's on Bill Wake website, and this is the URL. So they had a workshop with Kent Beck, and they started implementing games, and they made these drawings. So you start with the full Tetris, then you imagine the simplest variations that you can. So one tris, you have a single column, and what happens is that the only thing that you can do is you can leave it go, or you can accelerate by making the pieces fall faster. So you can die slowly or faster. This is not very fun, maybe, but it's good for starting with TDD. Then you can add the collapsing rule. So when a row is full, the row disappears. Or you can move in the direction of widening the columns, 2 columns, 3 columns. You can add movement. So basically, you have the seed of the problem and many orthogonal axes of complexity. And you decide which one is more interested to you. So you can work on how the pieces move, of having different shapes for pieces, or having reasoning what happens when two pieces touch each other, what happens, do they collapse, do they not collapse, scoring, levels, sounds, high scores. You work on the thing that is more valuable to you, and the thing that is more interesting to you. And Francesco Cirillo, when I saw him at the Java Day in Rome in 2009, maybe, This example was a hotel reservation system. So the simplest system it started from is an hotel that has a single room and the calendar that has a single day. So the first test is that if the room is free, you can book it. If the room is booked, you can't book it. And then you can decide to add more rooms, add more days in the calendar, add types of rooms. I want a double, I want a single, add bookings for more than one room. So you see how the complication grows, but you do it stepwise. You start from the very simple thing, and then you add little bits of complexity one by one. TDD allows you to do this because you start with a simple program and you continuously change it. It's not like you start with a structure. I know I need to have these tables, these columns, and this one-to-many relationship between days and rooms. If you start with this, you're starting with a complicated design from the start. And this blocks you into your initial idea. You don't have the benefit of starting with something simpler and seeing that maybe there are different ways to solve the problem, and maybe there are simpler ways to solve the problem. Generally, I find that when you follow TDD and you put a lot of care in it, the programs that come out are much, much simpler than what I would write if I didn't do TDD. Even though I don't remember how I did it before I learned TDD, because I now use it almost every time. So this leads us to the topic of emergent design. Emergent design is something that you might have heard about. Did you? Do you know what emergent design is? So the theory goes that extreme programming started by doing the opposite of what the conventional wisdom was at the time. So in the mid-1990s, the conventional wisdom was that you start with an analysis phase, then you do a design phase, then you do a coding phase, then you do a testing phase, and then you're late and you keep testing until it works for a lot of time. The reaction of agile methods and extreme programming in particular was to say, no, we break what we want to do in single things that are valuable for the customer, are user stories. So I must be able to book a room, to book a double room, to book 2 rooms for a period, to book a room for 3 days. And these are all things that we implement separately. And we do it incrementally, and we don't want to anticipate anything. Because every week, the customer might change their mind and tell me to do something else, because the customer has learned that now they need something different from what they told me the week before. And in order to be able to do this, to change what we are doing, Craig Larman says turning on a dime for a dime. Turning on a dime is a way of talking, English way of talking that is you can turn on a slit of space as a 10-cent coin. So being able to turn very tight. And for a dime means that it should not be expensive. So I'm quickly able to change my direction for not too much a cost, because this is where the money is. If the customer learns that there's money to be made in that direction, I'm able to follow him and give him what he needs or she needs. So this was the initial idea of extreme programming. But in order to be able to turn on a dime for a dime, I must travel light. If I have a big structure that was decided months ago, it's difficult for me to change it, because it's not optimized for change. It's optimized for solving the idea that we had months ago. So extreme programming does a different optimization. We optimize for being fast in reacting to changes, because this is where the money is today. The companies that work in a digital landscape will make money when they are able to catch new ideas and implement them quickly. It's the faster fish that wins, and not the biggest fish today. Do you agree? So this is what we aim to do with extreme programming, and TDD is one of our main tools. And something that goes with TDD is emergent design. So if I can't afford to have a design phase, I can't afford to have my design before I start coding. So this means that I start with no design. Or maybe I start with a very little design. I design briefly on the whiteboard with my colleagues, and then we start coding. Is this foolish? Is this non-professional? No, it's not, because we have a method. Our method is to build complexity in and continuously simplify the code and add the structures that we need when a test proves that I need that structure. So when I have a code that is becoming too complex because it has too many ifs, I start to simplify it by generalizing, not before. If I start with what I thought before that was my need, I will end up with something that is difficult to change and will not be adaptable enough when my customer changes their mind. So emergent design is the idea that you can have a good design that emerges while you work. So is this true or not? Does this work in practice? In practice, this works in the small to medium scale. What do I mean by this? It works in the sense that you don't really start with nothing. Before you start working on a new major project, you have an agreement with your stakeholders of what you will be doing. So you have some major blocks decided. You'll decide that you'll have a database. Perhaps you'll decide that you will use technologies that are mandated by the company. Not everything can be mandated from the start, because if we block all degrees of freedom, our programmers will be limited in finding the best solution. But it makes sense that you can't have a different type of database for every project, because that will make the work of operations too difficult. So you start with some idea of where the major building blocks are, and if there are more teams in your organizations, you probably want to get an agreement with the other teams of when your system will talk to their system. So you have a design in the form of drawings on the whiteboard with a box that is my system and a box that is your system, and a line that says, we'll talk to you at this time with something that looks like this, and probably it's going to be an HTTP REST request. Nothing more than this. What goes inside the box, you can design incrementally with TDD. So these will find different reactions according to what kind of programmer are you. Do you know who these guys are? Who knows the names? Rasmus Berdorf, the inventor of PHP, and this one? Come on. Come on! This is Rod Johnson, the inventor of Spring. Do you use Spring? So the character of these two guys is very different. Rod Johnson is a kind of guy that will like to reason about large structures, while Rasmus Lerdorf is something that wants to solve a problem quickly and gets down to programming immediately. And I'm not saying one is superior to the other. I'm saying that they will have different reactions to TDD. So according to what kind of programmer you are, because most of us tend to gravitate towards the one or the other pole, we will have different reactions. For instance, a hacker will say, it will probably don't do enough refactoring, even though he thinks that he's doing more than enough. But in fact, he's not doing all the refactoring that is needed to do TDD well. And this is not an actual quote. It's something that I invented, that I imagine a hacker would say. And the architect do something different. He will not resist the temptation to start designing before he has the tests. So he will do what we call design-driven testing, or DDT. And probably will say something like, I'm experienced, guys, I've done this before, so I know that we will need these and these and these and these. Again, this is something that I invented, not something that is an actual quote. So what is design-driven testing? It's something different from TDD, and goes a bit like this. You think the solution, you imagine the classes and the design that will implement this solution, and then you write tests that assert that these classes and functions exist. Note that now I'm testing the existence of a design, which is different from what I started before. I told you before that good TDD starts with tests on the problem. I start modeling the problem with examples, not modeling the solution with boxes and arrows. So if I write this test, the test will fail, and it will take a lot of time to make them pass. And I'll debug, and then what happens? I spend a lot of time with the broken red bar and will not get the benefit of TDD. So this is something different if you start from a solution. One problem that both kind of programmers may have is that they will tend to do bad object-oriented programming. So many programmers, especially in the Java community, think they're doing TDD, but they're not. What they're doing actually is database-driven programming. And you can see the difference because when you do good object-oriented programming, you start with the behaviors of things. When you're doing database-centric programming, you start with the data and the relationship between data that you think you will have. And there are two different approaches. There are different properties. The object-oriented approach has the property of being easier to change. And this is why in extreme programming we favor the object-oriented approach that says the database comes later. First, I think about my behaviors. So, Kent Beck said that you should refactor until your code passes these 4 rules. It passes all the tests, okay. It clearly expresses the intent. So it should be clear enough that when your colleagues read it, understand what it does. It has no duplication, so no copy and paste, but also no repeated structures, no concept duplicated in many places, and minimal, in this order of importance. So it's okay to add duplication if it makes my code clearer. And Reisberger said that you can simplify all these in these 2 states. So you remove duplication by finding an abstraction, and then you improve the name of the abstraction. But by doing this, you may notice more duplication, because, this thing is more or less the same thing as this other thing. Then you remove more duplication. And this is an engine that simplifies your code. In order to make emergent design work, you have to know about design. Because in the end, it's not the tests who do the design. It is you who do the design. And you can do it better if you know what are your options. So these are all about learning options on how to remove duplication, how to decouple, how to achieve more cohesion. So studying is no substitute. TDD is no substitute for studying object-oriented design. And if you keep doing it for a good amount of time, eventually you see that you start finding solutions that drastically simplify your life and your code, and you start deleting code. Your code base becomes smaller and becomes easier to change. But you will never have a code base that is easy to change because you identified the points of change before. Because when you identify the points of change, or the points of variability up front, you are guessing. The reality will be different. So if you allow the code to teach you where it needs to be generalized, because there you see where the pain is, you see where the smells are, then you will have a code that becomes easier to manipulate because you train it to be easier to manipulate by learning to make the changes that are actually required by the customer, not changes that you imagine the customer might want someday, but what actually the customer asks us to do. So this is what I was telling you before. So this is something that we in ThoughtWorks generally use to share with the customer what we will do before we start doing a major new development. There is some design, but mainly it is about identifying where the new thing will live, what it will talk to, etc. Then when we do development, before starting a new user story, generally we agree with the pair who will do the programming what we are trying to do. Then we write the tests one at a time and simplify as needed. What happens? That first test, you have a simple thing that does one thing. Then you add another scenario. Probably you have to add an if to cover that scenario. It's okay. If nothing happens, you keep this. If you have more behavior to implement, you add another if. At some point, you have so many ifs that it starts making sense to break the thing in two, etc., etc. And eventually, you get, by adding new cases, you eventually you will find what are the abstractions that make your code simpler. This is not easy. The first thing that you find, the first thing that you think is the right abstraction usually is not. For this reason, it's good to avoid this pattern that you have many actions that share a big bunch of logic, because this logic tends to be difficult to change. It is better to have some duplication between action logic and keep the shared logic to a minimum until you find the good idea. So you tolerate some duplication between different actions until what the code is suggesting you to do becomes clear enough. And especially, avoid the bureaucratic tests. So this is the kind of test that you write when you imagine a design and want to prove that it exists. So the button should be connected to the action. So I'm telling that the button get action listeners is a list of one element, and the action listener that is in this list is an instance of this class. And how do you pass this? By doing this. This is bureaucracy. You are asking permission to write the line of code that you knew you wanted to write. So this is like, oh, can I write this line of code? Yes. A stamp of permission, and then you write it. This gives you no value. It could be. So when you are exploring, you make learning tests. So the tests are not about the problem, but you do tests to learn about a technology. And some of these tests you might keep, some not. So if you're learning to use Postgres, we don't have a lot of doubts that Postgres works correctly or changes without notice. So at some point, the tests for Postgres we throw away. But if we're working with some bunch of other people who are writing a module that we depend on, well, maybe we keep the tests, because if they change it, we are notified because one of our tests breaks. Do you have questions so far? Do you have objections? Do you strongly disagree with what I said? So first, you have to ask yourself, do I really need to make a multi-threading solution? Because often, very often, programmers that are told, this must be performant, they start by imagining a world of threads that talk to each other. And this generally, many times, is not as performant as they think, and it can have deadlocks and other problems. So But the first thing that TDD does is maybe you don't need it. So you start with a single-threaded solution, and until it's not fast enough, or you have some logical problem that requires you to do two things at the same time, then you don't add threading. But suppose you need to add threading. Think web applications. Web applications are highly concurrent programs. Yet most web application programmers are not bothered by deadlocks. There are many problems in web application, but deadlocks are not one of them. Why? How do they do it? So you delegate or concurrency control to the database. It's the database that makes sure that if I'm updating the same object in the database, the two things will behave the way I expect. I'm avoiding your question in a way. So one thing, there's two things you can do. One is to adopt a design that minimizes the chance of deadlocks. For instance, the actor model of Akka and Erlang is good for this because deadlocks generally are more difficult to achieve because it relies on asynchronous communication. It requires you to have a different mindset because you have to learn to program with asynchronous communication, but then the problem of deadlocks goes away because deadlocks happen when you have shared data. If you really need to have shared data because you're programming in assembler or something like this, then the only thing you can do is to make sure that, as you have done, the single thread in isolation works correctly, and then you have to reason about the composition to think what could happen. Otherwise, you can do the tester tests, which are try to load testing your system and see where it breaks. But these are not the tests of TDD. These are the tests of someone who tries to break the system. The tests of TDD are about helping me build the system the way, in the simplest possible way. So some problems are inherently complex, and this is why we should try to avoid these problems as much as possible. So test-driven development and databases are famous for being difficult to go together. And one of the reasons is that Ruby on Rails, the framework, 12 years ago, was extremely successful. And Rails as a framework ties your business logic very tightly to the database. Makes it basically the same thing. This is what makes it fast. So you can very quickly set up a database backend web application with Rails, but then it will not be as easy to change as an object-oriented program because it will be a database. It is based on the database. Your objects are tightly coupled to the database. And since Rails was so successful, many frameworks today do the same thing. So Play, for instance, Django, they all do the same thing. If you go with the object-oriented way, the database comes after. And Uncle Bob often says that the database is just a detail. This doesn't mean that the details are not important. It means that in the context of a business that must move fast, we're talking about the core business of your company. The core business of your company is complex and changes fast because the market changes fast. So these two things means that a solution like Rails does not work well for you because you have to the structure of the database slows you down. Pure objects that live in memory without connection to the database are easier to change and easier to reason about. You can use the sandwich pattern. The sandwich pattern says that first you deal with the infrastructure world or the non-functional world. Then you do something that is functional, pure logic, and then you go back to the world of infrastructure or non-functional. So you load a collection of objects in memory from the database. You apply some business logic operation, and then you save the differences back to the database. So you have separation of concerns. Here, you can have the freedom to implement your business logic in the most clear and simple and error-free way as possible, because you're not bothered by these problems, saving the state to the database. You do it later. And Francesco Cirillo used to say, separate functional concerns from non-functional. Everything that works with the external world, network, databases, files, UI, it's non-functional. The functional thing is what is precious for your application if you're working with the core domain of your company. If you're working with a supporting domain like, I don't know, addresses for the telephone address book, or pays, contributions, payroll, these are all supporting domains. You buy products for those. If you have to implement them, they're not your core business, so you go with something like rates. But if you're working with the core business of your company, then you probably want to do something like this. Have your business logic, pure logic, not contaminated by database. There's also this diagram that I find helpful from Peter Harkins, which is a programmer on Ruby on Rails. So if you divide things, your classes, from immutable to mutable and functional to non-functional, you have that in a well-factored system, immutable objects that are purely functional are the value objects. Mutable objects that are functional are entities. So money is a value object because money doesn't change. €5 is €5. If I add €1 to €5, I have another object which is €6. Entities change. The things that are important to our business always change, like a bank account, a customer address, an invoice, or things that change over time, but still are or should be purely logical. Now, where do the non-functional comes in? You have services, repositories, things that bring you the things from the bridge from the functional world to the non-functional world, like here. This is a service. Generally, it is stateless, because the state is in the database. There's no reason why my repository should change state. What would go here? Any guesses? What is an object that is non-functional and mutable? One example could be a procedure that does everything, what Martin Fowler calls a transaction script. So first thing you do when you solve a problem, you have a program that takes input, computes an answer, and saves it to the database. Does everything in a single script. That would be, a transaction script would be something that goes in this quadrant, but is not something well factored. Over time, your transaction script should be factored into something like this. Otherwise, it will become unmaintainable. So what is here, unfortunately? The active record object and the JPA object are all things that live in this quadrant. They're both non-functional, because the JPA object is something that goes to the database, so it's tightly bound to a database table, and it's mutable. And I think that this is not a good place to be. So the rule of this quadrant is that a service repository can call an entity can call a value object, but not the other way around. So this helped me to avoid design mistakes. Like sometimes I have the temptation to have an entity contains a repository. Seems a good idea on the surface, but it is not. For instance, an employee knows all his the day he has worked, and so that it can compute the payroll. So it makes sense to have the employee object have a repository that returns all the days that he has worked in a month. But it's not a very good idea, because this makes my entity object non-functional. It's much better that in the sandwich pattern, first I have a repository that returns my employee and gives him all the days as value objects in a field. So my employees has days I have worked field that contains a number of day object, worked day object. So this way, by following this quadrant, you get to a better design that's more maintainable. And that's about it. Do you still have questions?
So the question was, why haven't I mentioned behavior-driven development, or BDD?
Not because I don't think it's valuable. I think that in the broad umbrella, TDD and BDD are cousins and do related things. I tend to not use a Cucumber or these sorts of tools, but I still tend to reason in the same way. So when I start, the examples for my user stories tend to be like when I have $100 in my bank account and I withdraw $20, then my remaining balance is $80. So I tend to use the technique of BDD. BDD is valuable because it pushes you to reason about these scenarios with your business people, to clarify if your understanding of what the customer wants is correct. So it's a very valuable technique, and let's say it's a different chapter of the same book.
How do I TDD with, for example, external system, external modules? Do I have to mock them, or there are any any other solution? Okay.
Are you thinking about objects that are built by your organization or things that are external?
Both of them.
So there are a number of techniques to be used in this case. So generally, we need to have both kind of tests. So you want to make sure that your system does what you think it should do. So you test it in isolation. And you also want to test the interaction between the two. But there's a third kind of test that you probably want to have, and is a unit test of their system, a consumer-driven test. So you are the consumer of a service made by him. I write a test of the things that I depend on when I'm using his system. And if I can, I make a pull request on him to add my test to his repository so that they don't make the mistake of breaking something that is important for me. So three sets of tests: my system, how it uses their system, and the combination of the two. Of course, the test that goes in the combination of the two is more expensive. It's slower and more difficult to get right. So I make a few of those. The others are much more numerous.
How can I introduce TDD to my project manager and convince him that this is not wasting time?
The answer is you don't. You don't. So the first thing that you do is you learn TDD. Because you can't go in your company and say, we should all do this thing that I learned. Well, I learned about, but I can't do well yet. Because that would cause resistance and problems, and will not do good for your employer. So first, what I would do is to study, do a lot of exercises to make sure that I understand how TDD should be done. Because it's very easy to explain, but it's not easy to do well. Especially what happens is that if you can do TDD when you have time and nobody is putting pressure on you, and you don't have, you're not afraid to fail, then it's okay, but it's not good enough for work. When you're doing work, you must be able to do TDD well, even when the customer is shouting at you, and you have pressure, and it's getting late, and you have to deliver by 7 in the evening. Okay. This means that you must have training. Like the US Marines say that when the enemy is attacking you, you fall back to the level of your training. So you do the things that you do automatically. When you get to the point when TDD is automatical to you, then you introduce it in your company, and you don't need to ask for permission, because this is how you write code. So just like I don't ask permission to turn on the light because it's dark, and I don't ask permission to go to the toilet, I don't ask permission to write tests, because this is how I write code. Okay. And I let my result speak for myself.
Thank you.
Thank you for the question.
Hi, this is actually a question about mocking. In the last month, I saw a lot of code that had many dependencies. So to test a single class, you have a lot of dependency to inject into the class you want to test. And the tests I saw were written by mocking each of the dependency in a very often in a wrong way. So they mocked the method they expected to use, but without respecting the context each object implemented. So for me that all the tests that were written were useless, because they couldn't test the behavior of the object, because the dependency were behaved in a different way. So I'm thinking that mocking is actually a bad practice if you are not forced to use it. You are not forced to use it because you have control of the system. So I'm pushing to something that actually tests the whole stack of the dependency, bringing up the system with something like an in-memory database of that kind of approach. Do you think it's a good idea to?
So there are many things in your questions. So generally speaking, if writing tests at the scenario level are good enough for you to enable to write your code, then you're probably good enough. So you don't always need to test every single class with a unit test just for that class. You only do that if there's any doubt that that class will behave differently from what you think. Having said this, the problem that you observe with tests, I don't know, because I haven't seen your code. In many cases, these problems are given by the fact that the class you're trying to test does too many things. So it's generally not cohesive enough. Or it does too many things, or it does too little things. So sometimes people who program with mocks tend to make very many small objects that do very little. And when you have these many objects too small, they don't have enough of a business purpose to exist. And sometimes the best thing you can do is to inline them into a larger object, and then try to break them down in a different way.
An example is the implementation of the DAO pattern, for example. It forces to implement always the same basic object with no benefit.
So the problem with the DAO pattern is that often, again, I haven't seen your code, but the problem that I see often is that you have too many DAOs. So if you think about the sandwich pattern, where is it? Here you have a repository, but you don't have a repository for every table. You have a repository for every business problem that you have to solve. So if you have a repository to find an order, then the order will have all its attached data built in. And this means that the order repository will use many tables to build your object. So it will reduce the number of repositories that you need. I don't know if this
yes.
can solve your problem.
This is the approach that I'm pushing to, but actually it's not so easy.
You're fighting against the prevailing mode of working of Java developers. And the prevailing mode of work of Java developers is database-oriented programming. And I can imagine it's a problem, because when you hear about test-driven development and object-oriented programming, you tend to have an expectation, and then it's difficult to have this expectation realized in your work. And many times this is because you're not really doing object-oriented programming, but database-oriented programming. And there are different things. It's not that database-oriented programming is bad. It has its place, but it has different properties. It's not as easy to change as object-oriented programming. Have I answered your questions, or do you have other?
No, it's sufficient. Thank you.
Thank you. One other thing is that mocks are explained very well in the book by Nat Price and Stephen Freeman. So I think I have it in the very beginning of the slide deck. Because here. This book changed a lot of my understanding of object-oriented programming. It's very good. Growing object-oriented software guided by tests. And these guys invented the mocks. So they tell you how they use them, and they will give you an idea of how you can be productive with mocks. Okay, do you have questions about ThoughtWorks, the company I work for? Maybe we are pioneers in agile methods. I've not been with ThoughtWorks for a long time, only 2 years. Jaker, my colleagues over there, has been with ThoughtWorks for 8 years or something. Yep.
Maybe could you tell us your typical day, working day?
So the typical day for a ThoughtWorks programmer, because he's a very good experienced designer, and I am a programmer, but at present I'm not in a delivery project. So let's say I'm doing pre-sales and consulting these days. But a typical day of the in a software development delivery project that ThoughtWorks does. So it starts if you're in India. It starts in the morning. You have a stand-up. Then after the stand-up, everybody says what they're doing, and then you have sign-ups, which means we are at the whiteboard, and we decide who's pairing on this story with me, who's pairing with on this story with another, and then we go and spend the morning working on the user stories. And at about 2, we have a call with Italy, because our customer is in Italy, and it's morning in Italy, and about lunchtime in India. We have another stand-up with them. Generally, we discuss doubts about the business problem. Often, we have technical discussions after the stand-up. So some people stay in the meeting longer and discuss something. Typically, it's about how to integrate the system we are building with what is already there in the enterprise. And then when the developers think that the user story is finished, we do something called the dev box, which is we go with the card to our business analyst and with the QA person, and we say, we are finished, please have a look. And so they briefly check what we have done. Usually they tell us, you missed this and this and this, so we go back to work some more. And if instead they are satisfied, the story is put in ready to test, and then will be tested more thoroughly by the QA people. And at the end of the iteration, we'll have a showcase, which means a demo in Scrum terms with the customer. It will be done, if it is a distributed project, we do it over the video call. We demonstrate what you've done, talk with the customer, and then we have a retrospective. I don't know what else to tell you. We generally work no more than 8 hours, because we know that after 6 in the afternoon, we tend to make more mistakes than to destroy value and not create it. And that's it. And once a week we do a team outing. We go out for lunch with the team and in a nice place.
Don't repeat yourself. Keep it simple, stupid. You aren't gonna need it. Can TDD help me to reach these principles?
Absolutely, absolutely. They help you because you have the tests. So when you see something that is not necessary, you remove it. And if you were right, the tests are still green. If the tests break, it means that, this was needed. So the tests enable you to avoid building things for the future. Because you know that when the need for something will arise, it will be because I have a test that proves that until I make this thing, the test will not pass. So this is the practices of extreme programming all support each other. So we have the test that support refactoring, that support simple design, and pair programming supports all of those because it helps me to keep my discipline, because I can't skip testing because I have my pair that will tell me, please write a test. This is not the way to do it.
I have a few questions. First is, I know that TDD is saying that I must write test first and code then. Do you follow that practice, or it is possible to write code first and test then? First question. Then, other question is about specification, project software specification. At what level the specification must or can arrive? I mean, I know you write user story, but then I stop there, or the software must be fully specified? Second question. And the other question is, maybe you answered before, but maybe I didn't understand. What about integration, integrated testing, SIT? I mean, TDD is suitable for work with a real database or backend system, or should I mock? So this is my three questions.
Okay, first one was about test after. So of course you can test after. That's a different thing from TDD. So I'm not saying that you must do TDD, but if you test after, it is not TDD, and you will get different results. Clearly, you are not benefiting from what we said before, that you only do things because they're needed, and you prove that something is needed because you have a test that is broken. And when you do the thing that was needed, the test passes. So you have a proof that everything you write is necessary. If you start writing your code and test after, then you probably have things that are not strictly necessary, and almost certainly your code will be harder to test, because you will have you will not have broken it in the pieces that make it easy to test. Second question was, remind me. So BDD is the kind of things that we do. So when you are into a user story that has some interesting business scenarios, you write the examples. So when think a good exercise, take Enjoy or any other car rental company. Look at the cost, how much does it cost. They will tell you that, for instance, the first, it will cost 45 cents per minute, and to the maximum of 60 euro per day. And when the car is stopped, it will cost 25 cents per minute. So try to think how you would implement the code that calculates how much you have to pay. You have to test many scenarios. So when the customer takes the car at 10 a.m. and leaves the car at 10 and 10 minutes, he must pay 10 times 45. When the customer takes the car at 10, leaves it at 10 and 10, but is stopped from 10 and 2 to 10 and 4, then the total is different. So you have a number of examples that clarify what is the idea behind a business rule. And this maps well to DDD because you have a test for each example. If you need a different kind of specification, sometimes the specification is this group must work with another group, but their software is not ready yet. So you write a specification in the form of a simulator or a stub, a fake version of their program that they will have to implement and make valid. So the specification is the signature of the interface between my system and their system. What do you have in place of a user story? What do you have? What is, in the case you're thinking of, what they give you instead of user stories? So when you have a Word document, what you have to do is understand what they thought. So you go to them and say, what happens when the customer takes the car at 10 a.m. and leaves it at 10:10? You have to reconstruct the meaning behind the document, because unless the document is written exceptionally well, and it never is, it will be very difficult to understand what they meant. So you will have to clarify, have a conversation, because the written word is a very inefficient means of communication. The most efficient means of communication is this one, me talking to you face to face. Over the phone is lower quality, over a document is a much lower quality. So we have to overcome this business risk, because if I receive a poor quality idea of what you want to build, I will most probably make mistakes that will be very expensive, because my team of developers is very expensive. So this is a very economic reason to make sure that we have a conversation. You had the third question?
Question is about isolation in testing, and I was wondering about SIT testing and database backend. What about how fit TDD in this kind of testing?
So if you are able to make the TDD the database something that you do later, then you have your code that works with an in-memory repository, and then you have to test that the real repository does the right thing, so it's able to reconstruct your object and save it. So you have a unit test for your business logic and unit tests for your repository. The unit test for the repository talk to the database, but do not do any business logic. It's only talking to the database. So it is unitary in my mind.
I'll repeat the question. Do you advise your customers just in the object-oriented world, or do you suggest they use different technologies, for example, functional programming or microservices, or you don't care and you say, and you investigate continuously in new technologies and you say, well, you'd rather choose this than this? And
we investigate continuously new technologies.
Okay.
And sometimes we love to suggest the most advanced things to the customer. Many times the customer is not ready, but when it makes sense and when it gives a business advantage, we suggest to use advanced techniques, like breaking a monolith into separate services. Let's not say microservices, but sometimes services are a good idea. And we also do functional programming. I personally am not very skilled in functional programming. I spent most of my time learning object-oriented programming, but if you are good in functional programming, why not? You can do flexible and robust programming in functional programming as well. Some of my colleagues are big fans of functional programming.
You know, I'm asking it because the current trend, at least in the cloud, is going towards microservices. It's kind of moving away from the old object-oriented world and trying to use it. So Node.js, functional programming, say Go or Scala.
Inside a microservice, you could have a domain model with many objects inside. But on a wider scale, if you really do microservices, then each one of your microservices is an object. It probably has state, communicates via messages, so it fits the definition of object, maybe a large object.
Yeah, yeah, kind of. Even if then they tend to do more end-to-end testing or stress testing, or so you shift the problem, but you have a different kind. So they tell you just make sure that piece of work works well under all conditions in the cloud, and then I'm fine with it. But they probably don't drill down into detail when they, as long as the code goes at least. Or my experience.
That's your experience. So
Up in now, yeah.
So the service is tested from the outside, but doesn't have a lot of testing inside the unit test of the objects.
It has, but it's just to say that you have 4 or 20 services communicating between each other, and it gets very tricky to test the whole system under load. And the only thing you can do probably is to deploy it onto in the cloud. So that's why they're probably doing it, because, or Netflix does, for instance. But yeah, unfortunately, but
I don't have a whole lot of experience on microservices, so I can tell you that. So guys, it's been a real pleasure, but I think I really have to go now. Thank you.